Hi, hello. I think we're starting our session today. Hi, everyone. I hope you are joining us. I have a very special session today. Hi, Ben. How are you?
Hi, Anna. I'm good, thanks. Yeah, looking forward to the workshop.
Yeah, me too. We're just giving a space for people to join, a few minutes extra so you guys can be here fully present. I see some people writing in the chat. For those who are already here, guys, feel free to drop on the chat where you're calling from. How is your energy? What do you expect from the session today? We always like to have, interactions with the audience and, get to know you a little bit better. So don't be shy. Feel free, to use the chat as you wish. Hello. Hi.
Yeah, it's always nice to hear sort of where people come from and kind of if they're working on any AI projects already or if they're in any kind of specific domains that are particularly challenging, that any kind of motivations to be here today
Yeah.
is also super interesting.
Yeah. Yeah, for those that are joining us, feel free to drop in the chat your expectations, projects that you're working on, where you're calling from. I see here Alison, non-face from High Alert Institute. Good morning to you guys. Yeah, I think we have a very international audience today, Ben. So, it's good morning, good afternoon, good evening for so many people. Well, I will slowly start and also give, these extra minutes for people to join, but I also want to give an introduction of today's session and, give you the formal welcome to our open source AI for social impact, a practical guide to getting started, and of course, with our wonderful partners at Hugging Face. Before we jump into that, I know you guys are here for this and to know all the ingredients to use AI open source. I want also to introduce ourselves as Tech to the Rescue, which are the organizers of the event. And Tech to the Rescue, we are a global ecosystem for AI-powered social impact. We connect change makers and social impact organizations with tech companies and funders to help proven solutions achieve scale and reach worldwide. How we actually do that? So currently we have two flagship programs through our AI Impact Lab and our AI Impact Scaling Program, which, by the way, I'm the leader of. My name is Ana Camerano. And through these programs, we help change makers scale proven solutions with AI. So our global ecosystem provides everything that impact organizations need for their AI transformational journey. So from the very beginning in building first prototypes to achieving meaningful impact multiplication. And this magic happens, I like to call it a magic. The magic happens, by partnerships. So we partner social impact organizations with professional tech teams that want to work towards AI and impact. So if you are here on behalf of a tech company or a software house, this invite is also for you to join our ecosystem. But because we believe that AI is an enabler of your impact, right? That's why we are here, and that's why we partner with Hugging Face. Hugging Face is the leading open source platform, the world's largest AI library with nearly 2 million AI models and 500,000 datasets. And what's best is that everything is freely available to explore and to use. So because of that, Tech to the Rescue and Hugging Face partnered and created an open source FAQ guide that answers the questions that social impact organizations ask the most. We linked the guide in the invite of this session. You probably have it in your email somewhere, but our team will also drop the link in the chat if you want to take a look. And I invite you to read it after the session today because I think things will get even clearer for you. So I think we can get things going. And today you're going to hear firsthand what's possible and how you can make the most by using open source AI. So I want to welcome Ben Burtenshaw, who is here with us today and who works with community education in AI at Hugging Face, who will lead the session. And Ben, the floor is all yours.
Great, thanks, Anna. Yeah, okay, so I'm going to take this session away, and it's a really practical one. It's not purely these slides, but they'll act as our kind of homepage, and we're going to go off to resources and materials all the way across the open source AI ecosystem. And I'll share all the slides afterwards, so you'll be able to access all of these links. So there's kind of no need to chase up as we go through. First of all, I'll introduce myself. As Anna said, I'm Ben Burtenshaw. I work in developer experience, community education. I'm a part of the developer experience team at Hugging Face, and our main role is to help individuals, communities, companies to use open source AI through the hub. And we do that by just building long-lasting relationships with these communities and sharing resources like tutorials or even applications so that people can build the stuff they need. Hugging Face. If you don't know, Hugging Face was founded in 2016 in New York. And at that point in time, it was actually, it's kind of an interesting story. It was started as a chatbot, principally. And in the development of that chatbot, the team found that the machine learning infrastructure, the AI infrastructure that they made for that chatbot was actually more useful than the chatbot itself. And it gained traction within the community, and people used the Transformers library, which was a Python library, which became one of the main ways to use open source AI models, and still is today. And now really Hugging Face is the infrastructure and the ecosystem around those models and more, really. We already had some stats, 11 million users, over 2 million models. It's important to say that it's not just large language models, it's also vision models, image generation models, there are data sets, and there are models all the way across the sciences into biology and into the humanities as well, and law and journalism. I'll show you a number of different entry points to the hub for different expertise levels, but there's everything from kind of app store-like UIs that you can use without any expertise, up to kind of production-ready, scalable infrastructure that you could serve millions of users with, are based on the hub, really. Okay, so we throw around the term open source AI quite kind of loosely. What does it mean? It's quite a contentious term. So before we get into the tutorial, I'm going to unpack what we mean and what we mean by open weights, because that's a better term than open source. Open source is a little bit loaded because of its long use in software. And truthfully speaking, not all open models are open source models. That said, open weight models are used to power some of the biggest companies, and actually the largest enterprises were some of the earliest adopters of open models because of their cost and benefits and access to sovereignty, access to privacy, and the ability to take models into their own networks or onto their own hardware and fix the performance and standard of that model on their own infrastructure, and not be dependent on third-party providers like an LLM serving API. Over time, open weight models have become way more accessible, and they're now being used by startups and individuals in the same way. So there's three really nice examples of leading edge startups, thinking machines, ML infrastructure platform that's built around training and serving open models, OpenPipe, a reinforcement learning platform, and Cursor, the really well-known agentic coding tool that trains and serves its own models. So now we can say that open weight is really being used at every end of the industry, and it's accessible to us now. That said, open weights are sometimes suspected. They're complex and very large files. They require infrastructure to serve, and not everyone has access to the expertise to kind of pick those things apart. Luckily, the hub comes with integrations for security and privacy, and many of these things are exposed and validated so that you're able to know that when you're downloading a model file, it comes in a specific format that is safe, known as safe tensors, and it's not a binary blob that is dangerous. And a lot of other infrastructure that we've built into the hub to make it kind of enterprise ready, but also really secure. And more recently, over the last 6 months, we've started to see even more companies coming to the hub and using it as a research platform and as an open science platform. These are some of the logos that have joined in the last 6 months, and they're using team and enterprise subscriptions to control their billing on the hub and to create teams that share applications and kind of collaborate together on the hub. So many of the stuff I'm going to show you today, you can kind of just fly by and take, but as you become a more established user of the hub, you can kind of bring your whole team there and start to collaborate on projects. Cool. So open source and open sovereignty, as I mentioned, these are major issues for enterprise. What do they mean? Let's unpack them a little bit. So one example is data sovereignty. Where does the data come from that the model was trained on? Is this secure? Where does the data come from that the model uses? Is this a local data set or something it has access to? Infrastructure sovereignty. So where is the model that we're using being served? Is it being served in a cloud provider? Is it being served behind an API, on a cloud instance that I manage? A local machine? Is it being served on the laptop that I'm using right now? There are various different degrees of infrastructure that we can run models on. And with open source and open weight, because you define the model that you use, you get complete control over this infrastructure sovereignty. You can say, okay, I don't need Claude Opus 4.6. I can use a very small, cheap model because the task that I'm doing is quite simple. Let's say transcribing notes. So I'll run that simple laptop on my laptop, a simple model on my laptop, sorry. And because I'm running it on my laptop, it's really secure. I'm not sending the notes from my meeting anywhere else, and I know it's safe. We can make these kinds of decisions with open weight models that we simply can't make with proprietary or API-based systems. And in turn, regulatory software, right? If we can define where a model is run, we can adhere to any kind of regulatory sovereignty because we define the geography of the infrastructure that we're using. So what we talk about often in open source is the open models. These are amazing for research and science, and they will expose the training code, the data sets that the models are trained upon, the model weights themselves, the architecture, everything that it would take for a scientist to recreate that model. And they're great and really beneficial, really important, but they're not the only models that we can use. The next stage would be downloadable access, and this is open weight models. So these are models that we might not necessarily have the data for, we might not have the code for, but we can download them and use them wherever we want. So that gives us all of the gains that I've just described, but it isn't reproducible for science. After that, we can then take those same models and we can access them through APIs. For example,
Oh, I think we are experiencing a technical issue. Hi, everyone. Sorry, just a moment. I think we lost Ben's internet. We're just reaching out. Oh, now he's back.
Really sorry.
Hey, Ben, we lost your room.
Okay, really sorry about that. I thought that wouldn't happen.
No.
Okay.
I just hear your feedback on the sound.
Okay, I think that should be okay now. Is that all right with the sound?
I still hear myself. No time for no joke, guys. No.
Okay.
Is it right? I think we can go back to you.
Yeah, cool. Okay. So yeah, sorry about that. I was pretty sure that wouldn't happen. So as I was working through this spectrum, was I up to API access? Correct me if I'm wrong. Cool.
Yeah.
So, okay, we've got companies like Together, and they take open weight models and they serve them, and we pay per token. So, in essence, we have many of the advantages that I've talked about with open weight models, except we don't define where they're inferred. What is advantageous about this type of usage is that we can easily move to the right because we've used an open weight model. So we know what's under the hood. So we're saying, okay, I've got full transparency over when I over what I'm using, and therefore I can take what I'm using and move it to different infrastructure and kind of move to the right. If I go kind of beyond this dash line to close, no access, or gradual stage release, I get some of the most advanced models, really state-of-the-art models, but we're dependent on the decisions of those providers, and we don't have any of the benefits that we discussed in the last few slides. So that's the kind of takeaway of why open source is important and why it's useful, and really why it's impactful to social impact companies that benefit most from these kind of issues. Cool, double checking. Cool. Okay, so let's move on to the tutorial itself now. So we're going to work through 6 topics, and the 6 topics are here. They're chat, agent, search, transcription, image and video generation, and document understanding. So there's 6 kind of core principal ways of using AI. And I expect that some of you will be more interested in some than others. And so I'd say if you're really interested in one of these topics, you kind of want me to circle back over it, spend more time on it, then feel free to just ask questions about it and let me kind of riff on that, and I'll take my time over it. And I think that'll make it a bit more dynamic and let me focus on the stuff that people are interested in. We're going to work through a kind of a graded set of complexity from inference providers, inference endpoints, and local deployment. And I'm going to show you examples that you can use right away. So let's just give you a quick.
Oh no, I think we had the same issue again. I'll have, to think of my jokes repertoire in case this happens.
Okay.
You're back now, Ben.
Okay. Yeah, I'm not sure why that's happening. Okay. Right. Let me just start up again where I was. Okay. So I want to start here with these 3 products, right? So let's just take a look at those. The first one is inference providers. So this is a tool for consuming model APIs, consuming open weight model APIs, and paying per token. So in short, you're given a code snippet, and you can use that to call a model on the hub. Let me show you how you'd find that through the model. So this is Hugging Face, right? This is the model repository where all the models are listed, and you can search for different models and you can filter them down. I'll come back into this later, but let's just take the first model here. And what I can see here is inference providers. And so I can just chat with this model here in inference providers. But I can also say view code snippets, and I can get examples of using models via inference providers. Now you'll notice this here. This is the OpenAI client. So in many cases, if you're already building an application that uses OpenAI, you can actually swap out these 2 lines here instead of what would be your OpenAI defaults. And you'll be able to use the same application code with this endpoint. And so you'll be on an open weight model. As I mentioned earlier, you'll then from there be able to go to local models or models deployed on cloud. So this is your kind of gateway to the open weight world using the same application. And what you'll see here is that at the top, we have different providers. So Hugging Face acts as a router for some of the leading AI inference providers, right? So companies like Nuvita and Together, and you can access all of these. You can in fact declare like a specific one to say, I want to use Nuvita, or you can use auto commands like fastest or cheapest. So you could say, okay, I just want the fastest provider for my application. Speed is really important. Or I just want the cheapest because cost is very important. And you'll get this snippet generated here. Okay, so next we can move on to inference endpoints. So this is a similarly named, maybe confusing product, but it works in almost exactly the same way from the client side, from the user side. However, it's fundamentally different because with inference endpoints, you'll deploy the model to your own cloud instance. So you'll go to the Inference endpoints application and you'll say, okay, I want this ZAI model that I chose here. And so you'll come back here to the same model page on the hub and you say, okay, this time I want to deploy with inference providers, inference endpoints. And you can choose a cloud provider now. So you can say, okay, I want to deploy this model on AWS or Azure or GCP. And you can then define the type of network that you want to use, whether it's open to the public web, whether it's private using an API key, or whether it's authenticated individually to your profile. You can then define scaling for the model's endpoint. So you can really go down into the details of saying, okay, how many machines, how many instances do I want to run to use this model? So we're getting to quite a technical level. I'll come back to this with other models. You can define inference engines and environment variables. You can even completely customize it and define the entire model runtime. And once you've done that, you'll be given an example that looks the same. Let me go to one of these tutorials. That looks the same as the OpenAI client that I showed you for inference providers. So here we go. You'll see the same client here is being used now via inference endpoints. So this is kind of step 2 on the ladder. The code wouldn't have changed, only the parameters. You would have gone from an OpenAI model to an inference providers model to an inference endpoints model by just changing the parameters. And for the last two, the model itself would have stayed the same, but the infrastructure and the cost model would have changed significantly because you'll say, okay, instead of paying per token, I'm going to pay for this machine to run. I'm going to pay the lowest possible cost, and I'll only pay when and how I use it. And the real advantage that we're talking about here is that ability to go up that ladder and then to go back down based on kind of needs. So the final one I want to show you is now running locally. So this time we're going to take a different type of model. We're going to look at GGUF type models. If anyone knows what GGUF is or doesn't know, just drop that in the chat and I'll see it there and I can go into more detail if I need to. So a GGUF model is a model that's been quantized in order to run on a local machine. And so quantized is a machine learning process that makes a machine learning model slightly easy, makes it run faster on smaller hardware. So you can take the same model that would require quite expensive compute and you can run it locally on your own laptop, relatively speaking, depending on the laptop and depending on the model, and you'll be able to run this locally. And on the hub, we have access to these same models, and now we can go to use this model. So we're not deploying anymore, we're just using them locally. And we can take tools like, for example, Llama CPP. Llama CPP is an open source library that allows you to serve the model locally. So you'll install the tool here. This is a Mac installation. And then you say, Llama server, run this model here, and it's the same model there. You can also install it on Windows. And once again, when you've used that, you'll use the same OpenAI client that I showed you for the last two. So you've really gone up the scale in complexity, right? From paying for tokens to paying for cloud instances to running it on the machine that you choose. That could be a laptop, as I've said, but it could also be a cloud instance or a server running in a data center or in an office that you have access to. There are other local apps than Llama CPP. There are examples like Docker Model Runner, which is a similar command but uses containerized applications. And then there are also more kind of user-friendly versions like LM Studio, and that's a UI application. If you open that, it will immediately, if you run the application, it will open up for you. And the same for Yan, another version. Let me just show you an example of that. Just by opening up their application, Yan AI. And this is a UI that you can run locally and run local applications. So the Hugging Face Hub is compatible with all of these tools, from LM Studio to Yan AI, and you can use them to run locally. And they're a great way of trying out models, and they are typically oriented around GGUF files. So models that are, let's say, shrunk in order to run locally. Cool. So that's the inference layer that we're working with.
And then, I know we're having an echo. I think it's your microphone picking up. So try to manage that. But I want to put your attention in the chat. We have two questions related to this part.
Great. Yeah, I'd love to hear them.
So we have the first one. Let me just see if we can fix this echo. See if this will better. Is it better now? Not really. Well, I'll go very quick. But then we have a question. Can encoder-only models support GGUF? And also another one, isn't Llama working with those? Let us just code. You can see the question on the screen now. It's better than the echo.
Is that true? Okay, so I'm just going to answer the questions. Is the sound quality better now? Cool. So, okay, the first question, can encoder-only models like WAV to VEC support GGUF? Technically speaking, yes, but in practice, there are other ways to run specific models like that. So technically speaking, quantization and GGUF support is a very generic process in machine learning, right? So it's about reducing the precision size that the model uses. It's probably a bit too technical for this context, but in short, machine learning models use float 32 points, which is a certain type of number, which has a lot of precision to it. And when we quantize a model, we lower its precision and we use integers, numbers that without decimal places, and they take up less space, and so the model is smaller. We can do that with any machine learning model, pretty much. However, there are specifics to how the model author would have trained the model, and and how they'd expect it to be inferred. And many of those complexities you kind of can't really define for every single model and every single architecture across the ecosystem. So that's what's happening here in this window when we go to this tab, is that we have a configuration files within the model repository itself. So we know the architecture and what's available to that model. And we pass that configuration and then collect a set of commands like these snippets, and we stick those together so that we know that these commands are valid for that specific model repo. And in practice, the authors of these libraries like Llama CPP, etc., they maintain this section of the page. And so we know that the two plug in together. So when you find a model on the hub and you have a question, does this run with this kind of inference engine? The kind of source of truth is the repo page, and in this question, the source of the model. Cool. So let's take another look. Let's go back to the slides. Cool. And then let's now work through these examples. So we've got 6 examples here. I'm not sure how deep I'll go into each one of them. Sorry, I missed question 2, didn't I? Will the Hugging Face on connecting local hardware inference? Okay, so question 2 is really the answer to question 2 is that last section that I gave. Yes, it integrates with local hardware. You choose the application, and the hub will point you to the application you choose. So if that's Yan that you've chosen, it will open a link to that Yan application with that model. And we collaborate with Yan and LM Studio and all those alternatives to make sure that there's a nice kind of integration between the hub and their platforms. Okay, so let's take a look at the first example of how you can use a model. So let me just refresh that page. Okay, let's create a new chat. And so this is a really familiar interface. This is just a chat interface, right? And I can work with a model here. I could say explain quantization in LLMs. And the language model, as I'm sure you're very familiar with, will respond in this chat, right? Now, what we're looking at here is just a UI that integrates with the hub. And there are obviously alternatives to this. There are alternatives to this with open source models. But what is useful about Hugging Chat as a platform is that it aligns with the same infrastructure that I've just been through, right? So inference providers, inference endpoints, and then local applications. So you can come here and try models out in quite complex use cases, iterate with them and get an idea of their abilities, and then take those models away to the infrastructure that you want to use to build your application. Or you could, in fact, just use these applications and kind of use these models, sorry, and just solve problems and go through that. In Hugging Chat, we have all of the main models that are served on inference providers shown here. You can select them, or you can use Omni, and Omni has a classifier in it that says how complex is this task, which model would be best for this task, and it can route you to a model. I'll come into some more things that Hugging Chat does through the duration of the tutorial. But the next thing I want to show you is Chat UI. Let me know if you've got any questions about Hugging Chat, but I'm going to come back to that as we go.
I'll use the moment to test again. We don't have an echo anymore, correct?
Okay.
Okay, good. Ben, we had a question in the chat. If you could, when you're doing the tutorials, if you can zoom in just a little bit, because the screen is a bit small.
Ah, yeah, sorry.
That's great. Perfect, thank you.
Sorry about that. Okay, so Chat UI is actually the software that Hugging Chat is running on. So it's identical. In fact, you'll see that just yesterday we contributed to it. So it's the same code that we're running in this application here. So even though this application is very familiar, it's just a chat application, right? The advantage of it is that you can try it out. We've exposed exactly how it works and the ingredients that it takes to run. And you can come over here and run the source code and use the same application. And in fact, we're deploying it in production. It's being used by tens of thousands of users per week. And so if you want to make sure the application is well maintained and is robust, you can benefit from those changes and simply use that. So that's the reason why we highlight Chat UI and Hugging Chat. Now, what I'm going to show you as I work through some tutorials are different inference examples. And all of these inference examples, you can use Chat UI plus that inference example. So in this first example, providers, second example, endpoints, third examples, local LLM. And then in the final one, we'll build a custom chat application without Chat UI, right? So for each of these chat examples, we're kind of swapping out the inference provider, but keeping the UI the same. And as we move up this scale of complexity, we go from paying for tokens to paying or even owning hardware. So, okay, let's take a look at this chat completion task that I first want to show you. So we have a series of examples here, and we can use the same chat completions endpoint from OpenAI. So what we have here, just to break it down even further than we did earlier, is the OpenAI client, the connection to the client, and this router address, the Hugging Face token, which you'll get when you join the hub, and you'll access it here by going to access tokens, and you'll need to sign back on, and all of your tokens will be listed there, and you can manage them. Next, you'll define the completions and you'll connect to the model that you wish to. So you can connect to different models. And here you'll see in this example, we are declaring a specific provider. So we're saying Cohere. But it could also be Fireworks. It could also be any of these examples. And we'll just simply swap out the provider. Okay. Now, what we can also do here is connect to different programming languages using JavaScript, but really it's just an endpoint. So we can actually connect in any programming language that can do a request, right? So it's very generic. Okay, another element that we can do, a tool that we can use in order to find that inference endpoint is the playground. And in the playground, we can add multiple models together. So we can say, okay, let's take these two models and let's say explain quantization. And now we'll get the responses from those two models side by side. So here, okay, we can see that Minimax is a faster model already. And we can review that, and we can review it alongside the GLM5 model served on Navita. Taking a while to load up that model. Maybe it's because of how I'm generating. Let's try a different one. Okay, so this model, there we go. So we can now see the two models generation side by side, and we can review those and say, okay, which model is right for my use case? As we said, with kind of everything along this way, we're always exposed all of the information. So in this case here, we're saying auto, which means choose any provider. And again, we know the model ID that we're using. We could specify the provider and say, okay, let's compare the same model on two different providers or compare across models and providers. But everything's exposed. So from this UI, we can work up the complexity or the maturity ladder. I think this is really useful for non-technical decision makers like project managers or product managers that want to understand the kind of the surface or the qualitative dimension of how a model is behaving in production, and then take that back to the technical team so that they can use that model and make those modeling decisions. Okay, so let me go back to my slides.
Yeah, and Ben, we have a question which I just want to confirm if what you just showed is the answer for it, right? Because Mara asked to understand model fit, if she should perform the same task or the same workflow with several models and evaluate the output, or if the Hugging Chat that you showed previously would do that for them.
So, okay, yeah, I think what you're referring to there would be Hugging Chat's Omni feature. And that is a quite simple feature. And to be honest, I wouldn't rely on it to make kind of like, decisions about your product. It's a simple feature that basically asks how complex is the query that the user is saying. So if the user says something like, explain the formation of clouds. This kind of information is in Wikipedia and many textbooks, and so you'd be able to expect a language model to be able to perform that explanation quite easily. So Hugging Chat would choose a simpler model. Or let's say summarize this text, or take these text and turn it into 3 bullet points. These kind of things would be achievable by very small models. Whereas if I said, here is a math Olympiad challenge that is unsolved by humans, then that would be a very complex task and might be at the very edge of what language models can do. And so the Hugging Chat Omni feature would say, okay, let's choose the largest, most performant model that's available, and it would choose that model. It's not perfect. Some tasks are deceivingly difficult for a language model. There's one at the moment that they're struggling with, which is there's a car wash 50 meters from my house. Should I drive or walk? And so these kind of roadblocks to language models are quite famous. So then it's not a perfect science. If you're building a product, I would say go to the playground and really get like a deep material understanding of what the text looks like that language models generate, and understand what fits best with the product that you're building. The example I've shown you here was very simple, right? Explain quantization. But actually, I could start to say things like, explain quantization to a machine learning scientist, explain quantization to a product manager within a machine learning company. Don't use full stops, only use prose. Define in one sentence, right? I can build up a prompt and I can get quite detailed, and I can look at things side by side and get a really good understanding of what it is that I need from my product. So that's definitely where I would come to make those decisions. Okay.
Yeah, and so we have a few more comments. I think this is a popular topic, but the comment from Robin is that, so this is kind of the first model that serves as a router to choose the one that will provide the answers.
That's correct. Yeah, it's a router. It's a classifier router. It classifies the complexity of the input.
Yeah. And the other question we have is that any models on Hugging Face are evaluated, or you guys have scorecards, evaluation ratings for bias, misinformation, energy efficiency, speed, etc.
Yeah, we do. So actually, I'm going to come to this later, but if you go to Spaces, Spaces are applications on the hub for machine learning. One of these along here is leaderboards. Model benchmarking, sorry, is the term. And you'll see a whole set of spaces for benchmarking different models. So you've got Open Arabic LLM leaderboard, Turkish benchmark leaderboard, memory model utility, calculate VRAM, Open Portuguese LLM. So really, we're benchmarking everything. And typically, these are maintained by scientists, research groups, and NGOs within that domain that value this area. If you look at something like code generation or text generation in English, there are many private companies doing this, right? There's Artificial Analysis, there's Harbour at the Lord Institute, like just to name a few. But typically, when you get down into more niche tasks, lower resourced languages, relatively speaking, there just isn't the availability of those kind of leaderboards, and it is quite expensive to benchmark models. So the institutions with access to do that are limited, and often they will share their work here as spaces on the hub. As well as that, we take a few of the core benchmarks. There are more coming in the next few weeks, actually. This is a very new feature. We aggregate the scores that the authors themselves share across the hub. So, for example, here we have ZAI has declared a score of 50.4 on this benchmark. This is an agentic benchmark. Now, these scores are to be taken with a pinch of salt, or to be taken in the context that they are given. So, in fact, that score comes from here, the README that the model author has added. So it's their proclaimed, it's their release score. It could be the case, it rarely is the case, but it could be the case that the model author is incorrect and that they've miscalculated the score for their own model. For large labs, it's rarely malicious, but evaluating models is difficult, and there are many different variables involved. So the scores are published. What we can also do is view scores like this one, which are defined by the community themselves. Sorry, I clicked the wrong thing there. Here. And so add HLE evaluation results with tools. So this means that this community member has opened a pull request to say this model achieved this score. And so what we have here is a kind of a social form of evaluation. In the coming week, we'll also release verified scores, and that will mean that we and other research organizations within the community have taken the model and re-evaluated it and shared a score. That will give kind of multi-factor evaluation to the community and say, okay, not only has the author evaluated it, but we've evaluated it, and they have the same score. From there, the community can still open pull requests and say it's still not getting the score, but it will give a degree of transparency that we think is pretty cool, and mainly will just allow people to start talking about the intricacies of evaluation. Okay, hope that was interesting and useful. I'll go back to chat unless there's any other questions, Anna.
No, I think we're good. I see in the chat from AI Content Club, I think your question before really didn't come through. If you want to paste it again. I see, however, that you got the answer somehow, so I hope we're good on that. But we can continue. I just want to do a time check. We have a little bit more than 10 minutes. We'll try to tackle all the questions that will come. If possible, we'll stay a bit beyond the time schedule, but I just want to make the time check as usual.
Cool, thank you. Yeah, so we've got quite a bit of time, but it will come down to questions. So I'm okay if we've answered some questions as we go.
Well, third time is a charm. Let's just give a moment for Ben to come back.
Okay, yeah.
Yeah, you are back, Ben.
Okay. Great, so cool. So, okay, let's now take a step forward and look at agents. So, as I mentioned, we have a part of our platform called Spaces. So, within Spaces, we can use MCP servers. So, MCP servers, maybe you're familiar with this. They are tools that models can use, that large language models can use to perform various tasks. And what's really cool about the hub is that, one, it is an MCP server. So actually a language model can use the hub. And two, all of the spaces on the hub are also MCP servers. So that means that when, let's take this one here. This is an image editing space deployed by FireRed. Okay, so we can upload an image, we can add some kind of edit to it, and we can get back a result. So let's say, it usually works. So we can take an example like this, see how it works. And we can use the space just to try out the model and just to see how good it is, if it does what we need. But we can also use it as an MCP server. And so I'll show you what that looks like. So we can connect to MCP servers from our preferred UI. We can log in. Let's say that is something like Claude AI. Then you can go to connectors and all the documentation is there, and you choose Hugging Face, and then you can connect it to it. And with Hugging Face as an MCP server, it means that you can call that space that I just showed you. So you'll be able to say, edit this image in the same way that you can use the app. Yeah. Cool. It's taking a while, this space. And so, okay, but what you can also do is use the hub as an MCP server. So you can say search for models, collect a list of models that work with this hardware, et cetera, et cetera. And so now we can see that examples run and it's edited this image. So not only can you use the hub through Spaces, you can also let agents use the hub through Spaces as MCP server. That's the takeaway. I also shared Chat UI here, and what's really cool about Hugging Chat, is that it automatically connects to all of the MCP servers that you defined. So if I come here, I can say add a server. It doesn't need to be on the hub. It can be any server by any provider. And they'll appear here. And so you see these are the ones that I have, Web Search and Hugging Face. When I connect to Hugging Face, it will then have access to the image generation tools that I've listed. And they'll all show up down here. So for example, this image generation space is shown here. Text-to-speech space is shown there, et cetera, et cetera. And so all of those spaces that I choose will all be inside my MCP server. That's just in Hugging Chat, but as I said, you can use this with any of your favorite tools. Okay, and another thing I wanted to share on agents before I move to transcription is that we can connect coding agents like Claude Code or OpenAI's Codex to an open source local model. And there's a blog post on this, it's included in the slides. But in the same way that I was showing you how to build an application, you can pull this local model from the hub, you can run it locally. If you have a reasonably performant Mac laptop, this will, one of the latest generation, model will run on it. And then you'll be able to use Claude Code freely on this local model. That said, this model is not as performant as Anthropic's own models. So there'll definitely be a quality drop-off, but you're able to perform basic tasks and you'll be able to use it without an internet connection and for free. Okay, let's go ahead to transcription.
Yeah, Ben, before we go, I think we're going to go a little bit ahead of time just to say to the audience and for those who could stay. But we do have 2 questions in the chat, and I think we had a good interaction with people, so I would like to address them. One is there any built-in features in Hugging Face to evaluate the models for more technical use?
No, there aren't any features built in specifically for that. However, the hub does have, for example, a jobs feature, which allows you to run evaluations, and you can use open source tools like Inspect to do that, but it doesn't have any built-in evaluation functionality.
Okay. And we also have another question is what does Hugging Face do to ensure that there aren't risks associated with the published spaces?
So we have a moderations team that moderate all of the content on the hub, blog posts, models, spaces, data sets, everything. And we have CSAM and NSFW detection that runs on all of the resources, and the moderation team manage that. On top of that, we have community engagement around spaces and some of the strictest regulations around in the AI space. So we maintain a high standard through a combination of technology and community work and moderation.
Super, thanks. I think we can move on.
Cool. So the one example that I really wanted to show you here, let's see the time. I'll quickly show you this one because it is important. So this here is an example of how we can use inference providers for speech recognition. So in this example, we can't use the OpenAI client because it's specific, but we can call the inference provider and we can say, here's an audio file, convert this audio file into text. Now up here, there's an application which uses this same technology. So here's a short application for a custom Gradio UI. You could deploy this as a space or you could run it locally. And it uses inference providers to process meeting audio. It's in Python and JavaScript. So this is really easy to run, and you can run it on your local machine, and it will call the API. So that's pretty handy. Let me show you the next example. That example that I just showed you is also available on Inference endpoints. It's essentially the same example. It just uses a different deployment model, as I mentioned. But this one here is particularly cool. So this is an example of WhisperWeb. So Whisper is a model from OpenAI that is open weight. You can download it. And what that means is I can run this space here, and I can record audio, I can upload a file, or I can drop it in from a URL, and it will run, it will transcribe the audio inside the space. Now, what's really cool about this is that I can, in fact, run this model locally. I can run the space locally. I can access it in the browser, or I could go and turn my Wi-Fi off. I won't do that now for the sake of this call. But we could turn the Wi-Fi off and the space would still run because the model is running in the browser. So if you're working on meetings that are sensitive, or you're working in contexts without a readily available network connection, you can transcribe meetings to a reasonably high standard with this space. But there are also more performance spaces available on the hub, depending on the kind of resources you have available, the hardware you have available, and you can run these models locally. In my opinion, this is probably one of the easiest ways for social impact companies to get value out of AI, these sort of local models. Okay, we're coming up to time. So I'll encourage you to take the time to look at some of these other pages, for example, image and video generation with a progressive example again, document understanding with progressive examples again. As I said, Hugging Face supports images and documents. Hugging Chat supports images and documents that you can drop in here. And each section has a model that I sort of would say would be my first go-to for each of these tasks, so you can try that out. And that's all, as I've raced through it.
Yeah. No, thank you so much, Ben. I want to remind the audience that you'll receive, after we drop off from the session, you'll get it on your email, all the slides, everything that Ben just showed. maybe, Ben, there's a way where people could connect with you, maybe check you on LinkedIn, and so, because we do have a few questions that we might not be able to address as we are out of time.
Yeah, sure. That's all in the slides at the end. I guess the easiest way is probably to go to my Hugging Face profile. From there, it's got all of my social contacts, so LinkedIn and X and everything, and also all of the kind of spaces and models and papers that I share are all available on this page. So you can follow me and try it out.
Yeah, that's perfect. So I'm sorry for those that we're not going to have time to address the question, but at the same time, I want to thank everyone for being so engaged. And there are a lot of people very, very experienced here in using Hugging Face. I hint. So thank you so much for joining us. And for the organizations that are here, people representing social impact organizations, you can also register at Tech to the Rescue to learn more about our two flagship programs, the AI Impact Lab and the AI Impact Scaling Program. If you are yourself in this AI journey and wanting, to work on that with your social interventions. So thank you so much, Ben. Thank you. It was a pleasure. It was really like a masterclass. I learned a lot, at least. Very excited to explore more what Hugging Face has to offer. And thank you very much for joining us.
Thank you. Thanks for having me. It was really fun.
Yeah, thank you. And thank you, everyone.